It is like a private class. So how you got yourself a book, right? I got one of these for you. This should help you keep track of where you are a little easier to get the.
Oh, is that what I was supposed to use that for?
Yeah, do you have one? You have one?
Yeah, I have one.
So what you do is you put it like, what's the next lesson? This is the next lesson. So when you finish today, this is the next lesson and it's right there. You just move it when you finish a lesson and it just helps you get to stuff easier. All right, see how easy that is. There we are. What you do, then flip and flip and flip. And here we are for today. Look what you're doing on your work. Awesome. You got your binder or you don't have it?
I have my binder.
Okay, well, gotta make sure you can answer some questions. So let's see. All right.
Oh, this is in this game.
Always got to answer stuff. Okay, do I have anything to hand back to either of you? Let me see. They're fine. She's fine. We do this every week.
That's a book.
Let's see. I don't think any of these were yours. This is James and Caitlin and.
Wait, would you like to use a book class book during class? Is that what I'm supposed to do?
Yeah, do the binder work before class. Do the binder work before class so that you're ready when, so you do the binder work as you're reading. So as you're going along, you fill it out as you're reading the chapter and that should help.
Yeah, that's what I was working on this morning.
So, okay, good. It takes a little while to get used to everything, so that's fine. So yeah, it should make it easier for you. You did it. See, good job though. But see, now you know what's going on today. So you aren't gonna be sitting here like, I don't know, right?
My sister was leaving town yesterday, so we were
That's fine. Where'd she go?
back to Statesboro.
Oh, okay, for school? She in school there? Yeah.
She graduates this December, so she got
Oh, that's good. That'll be great, right? What is she graduating with? A degree in what?
business, I think.
Smart. That's a good one.
She's really smart though, so.
Yeah, business is a good one. She'll make some money. All right, I got money. Did you notice? I refilled the candy machine. Did you see?
No,
I put Skittles in it.
I'm just gonna take the money out.
Ah, he saves his money. What are you saving for?
I'm saving it for something for the game.
Uh-huh, which game?
Roblox.
Okay, you're buying stuff in Roblox. Yeah, $70? What the heck is worth $70 in Roblox?
Probably about maybe 5,000 Robux.
Is that what you're doing? What are you trying to buy?
It's something that you have to order.
Oh my goodness. Well, you're serious, huh, Cal? All right, so we're starting minerals today.
I love these Skittles, so
And this is where we get into the pretty stuff, right? But some of the stuff is really beautiful. Like you can see, I put some rock samples up on the counter today. Ooh, for anybody at home, look at the rock samples on the counter. Anyway, and those are going to be for you guys to look at after we do our rock hounding today. So let's get started. We're going to talk about properties of minerals. What makes something a mineral? Sometimes people will put a necklace with a pendant, like this is a pendant, right? It hangs. And sometimes it's a pearl. Is a pearl a mineral? Do you know? You don't know what a pearl is? So pearls, I have one little piece of jewelry over here that has some pearls in it.
it's a type of gemstone.
Actually, it's not a stone. So you see that? Those are pearls. Those white ones right there.
Oh no, pearls are from.
Pearls grow in oysters.
Yep.
So what pearls are, and they're really beautiful. So people wear them in jewelry. I have a couple things with pearls. So what people do with how they find pearls is they look inside of oysters, and sometimes an oyster will grow a pearl. And the reason it does that is because it'll get a piece of like sand or something inside of its little mollusk body, and it doesn't like that. So what it does is it produces the same material that it uses to make the inside of the shell. Inside of an oyster shell is really pretty. It's like shiny and smooth. And they produce that same material to cover that grain of sand until it is smooth and it no longer bothers them. And it makes a beautiful pearl. And then we use those for jewelry and whatnot.
Oysters taste good.
Oh, oysters are delicious. I love them. Have you ever had an oyster?
Oh yeah.
No? Do you like them fried, raw?
I usually get them fried, but sometimes eat them raw if I put
Love
some sauce on it.
Yeah, I love them raw with hot sauce. Yeah. So gemstones are a little different though. Gemstones are minerals. So that's the other thing people tend to wear as jewelry. So let's talk about the properties of what makes something a mineral. All right. So does anybody know the definition of mineral? Do you have a definition of mineral right there in your binder maybe? Do you see it? Anybody want to guess? Do you want to guess? Do it. What does it say? Do you find it?
Basically anything that's intelligent.
Very close, yeah, you're solids, that's right, very good. So minerals are definitely solids. Why am I not, why did it didn't move? Oh, hold on, I gotta connect and reconnect to the TV because it's,
Like you.
yeah, it doesn't like me and it's giving me trouble. Hang on 1 second. I changed the screen. Well, it's because we have a new everything over here and it's just, it doesn't love me, this new stuff. And I'm trying to get it to be friendly, but it's not always friendly. So it should disappear now. Oh, that's fun.
That I have
Let's try this again.
basement and like I try to connect like my game console or
Yeah.
my phone to
It
it.
doesn't want to play.
Yeah, a lot of times it's just.
This is, I've had no problem with this where this is concerned, but we replaced our media center and our receiver. And when we did that, now it's a little wonky. So like we upgraded stuff for other things, but it made this more difficult for me. All right, do your thing. All right, now we're on share screen. That's right. Go back to share screen.
Do you use NetU?
I don't think so. I don't know. Jason does all this. It's not me. This is not me. Okay, this should fix it. Please fix it because I don't have time for this today. All right, let's find device. And I'm hoping that in the next, probably not today, but maybe today if we have time. So my in-laws were here this weekend. And my father-in-law was a pilot in the Navy, a fighter pilot. And he actually was part of the Top Gun program a couple years after it started. So he's one of the kind of original Top Gun guys, which is pretty darn cool, right? And anyway, he gotta move this to minimize that. Anyway, he got 8mm film from when he was on the carrier. And there's all these like takeoffs and landings of these planes on the carrier, and it's really cool. So he brought it. So my husband, he does a lot of video editing for fun. So he edited it and it's incredibly cool. You can see some neat stuff. So I'll let you guys watch that at some point just because it's awesome. All right, so minerals, we were saying. A mineral is naturally occurring. We don't make it in the lab. Inorganic solid. What's the word inorganic mean? What's the word organic?
It's not natural.
Yeah, it means that it's not made, it's not once a living thing. Like, for example, that table next to you, Cal, that would be made of organic material because that's wood and it was a tree, it was once alive, right? So inorganic solid with specific chemical composition and definite crystalline structure. So crystal, anybody want to define a crystal? I'm gonna give it a shot. Do you see a definition for crystal?
Cool down, full of lava.
That's a good point. So crystals are solids and the atoms are arranged with repeating patterns. If a good example would be kind of like, if you were to build a Lego tower and you were using the same size block the whole way, you would probably build it the same, arrange the blocks the same way all the way up to make the tower. You're repeating that pattern all the way up. And that's how crystals are. Their atoms are such that they lock together in a specific way and they create a solid that's not squishy. It's nice and hard, right? It doesn't move around. So they have a definite chemical composition too. That means that, you can't go changing their chemical composition and have the same mineral. Doesn't work that way. So we just said what organic and inorganic are. So anybody want to try and define them again? Organic, inorganic? Do you want to try? That's inorganic, really very good, Cal. So inorganic is, there we go, not consisting of or derived from living matter. And then carbon is involved. The reason carbon is involved is carbon is the basis for living things, for molecules from living things. So you may hear the word like carbon-based life form. That basically means pretty much anything that's living. Most things are carbon-based. And then organic is going to be the opposite, right? It's any class of chemical compounds in which one or more atoms of carbon are covalently linked to atoms of other elements, most commonly hydrogen, oxygen, or nitrogen. So here's some examples of, some characteristics of inorganic versus organic compounds. So I want you to look at the one that says, I want you to look at the one about melting point right here. You see this? This is a really interesting one. So a good example of organic and inorganic compounds and melting point. If I had a tablespoon of salt and a tablespoon of sugar and I put them both on a plate in front of you, it would be difficult for you to tell which was salt and which was sugar, right? Especially if the granules were the same size, like sometimes salt looks smaller granules than sugar, but if you got, there's a certain kind of sugar you can get that's really small granules. So if you put them side by side, one way you could tell them apart is to taste them, right? Especially if I told you it's salt and sugar, so you know it's not something dangerous. But another way that you could tell them apart, if you put them both in water, what's gonna happen? Yeah, they're both gonna dissolve. They're gonna make a solution, right? So another way to tell them apart is to heat them up. So if you put the salt in one pan and the sugar in the other pan, turned on the burners, do you know what might happen? What do you think would happen, Cal? Do you know? Yeah, which one is gonna melt? The salt or the sugar? Do you know? Well,
A lot of cooking shows.
yeah, the sugar is gonna melt. That's how you get candy and stuff, right? You have melted sugar a lot of the time, like a lollipop, the sugar that's been melted and molded. The salt is not gonna melt, not for a long time. It has to have a much higher melting point. So melting point is a good way to tell solids inorganic compounds from organic compounds. And then there's the main thing about how they come from living things versus non-living things. So our inorganic stuff comes from non-living things. All right, so these are ways we identify a crystal. So we have crystal form, hardness, streak color, special properties. Oh, I meant to get something upstairs. Density and specific gravity, luster, cleavage and fracture, color and texture. Anybody want to try and tell me what crystal form is? Should be in your binder. I think it's in there. What's crystal form? You may have one in there. It says something like that, I think. See it? Let me see if I can find it in there. Let's see.
How do they form?
Here it is, right in here. If you can find it. Yeah, well, what's crystal? So crystal form, I'll give you this one. All right, so this is shape and the number of sides. You ever seen a crystal that has it's like a prism and it has like 5 sides to it? Sometimes it's just a square. Like if you look at salt or sugar under what you look at salt in this case under a microscope, they're little tiny cubes. So hardness. Do you know how we test hardness? What mineral do you think is the hardest?
And diamond.
Diamond is the hardest. You know, we use diamonds on cutting equipment, not just on jewelry. They use diamonds to cut things because they're so hard. And we use a scale called Mohs scale to determine how hard something is. Whoops, I didn't mean to click that one. So how easily it is scratched is how we deal with hardness. And you can scratch it with other minerals or other tools. I actually forgot to bring a couple things out together.
I used diamonds and some sort of metal paste. I forget which one it was.
Mhm.
It's really heat. It's the paste. And
Oh, wow.
CPU processing, but the heat or whatever, it went from like 15 degrees Celsius to like 13.
Wow, that's pretty cool. So streak color. What we do with streak color is we can use about 3 different things. Here's the one we have today. So this is a streak plate. And it's a glass streak plate. You can also use white ceramic or black ceramic. If you take the rock or the mineral you found, and you're going to do this today, you're going to use this streak plate. You're going to scratch it on here. And you're going to see first off whether or not it scratched the glass or the glass scratched it. And then you're going to look at what color it leaves behind. So you can put it against the white background, and then I have some black plates over there you can put against the black background too. So sometimes it'll help you see what color gets left behind. Because sometimes when you scratch it, they'll leave white or pink or black or whatever. And that gives you an idea of its color that we do streak color. Do you know what a special property might be? No? Yeah, special. Yeah, this is the one I forgot. I got to go upstairs and get my magnets. What if it's magnetic? What if it's magnetic? And then the other ones would be fluorescence, double refraction, and effervescence. So double refraction you get by shining a light through. Fluorescence is when you turn off the lights and it glows under UV light, basically. You know what a UV light looks like? Yeah, and it'll glow under UV light. And then effervescence is if you put it in water, does it bubble? Or you put it in a different kind of solution, does it bubble? So interesting thing about diamonds, if you want to know something is a real diamond, one way to test it is with a UV light. So you take your UV light and you shine it on, like I have this diamond here on my hand, right? It's my engagement ring. And you shine it on there, it'll turn like a purpley blue color. And if you turn off the lights in a completely dark room, it will stay that color for a minute. It will continue to glow and it'll fade out. It's actually really neat. It's a neat thing to do. I used to have, at the school where I taught, I had a little tiny office in my classroom and I packed my whole classroom in there just to show them that, look, turn the lights off because it got perfectly dark in there because there were no windows and they were like, woo, look at the one thing glowing on my hand. Kind of neat. All right, so density and specific gravity. All right, do you know what density is?
Mass.
Close, it's partly mass. Uh-oh, who's calling me? Give me 1 second, make sure this isn't. Hello? Oh, it is what I thought it would be. All right, sorry. If I don't push this button to tell them to send my medicine, it becomes a thing.
Oh, that's good.
Oh, well, they'll call back actually, I think, I hope. So it takes too long. They ask me like 90 questions, I have to be pushing buttons. I'm gonna do that while y'all are here. So density is basically how much matter is contained in the volume, given volume. Okay, so like my apple here that I've been munching on all morning, this piece has length, width, height, all kinds of dimensions. So it has volume, right? All right. It also has density. How much apple is squished into that slice. And then specific gravity is a little different. So your density, you find it by taking mass and dividing it by volume. With an apple, it's gonna be hard to find the volume because it's all those weird, weird shapes. But if you had a perfect cube, it would be easy to find the volume. You just do length times width times height, and that gives you the volume of the little cube, okay? For your specific gravity, you take the density and then you divide it by the density of water. So this is the basis for comparison. Density tells you how much of something is in a given volume. Specific gravity tells you how that compares to basically everything else, because our standard we use is water. So if you put a wooden block, like the kind you build with, in a bucket of water, what will happen to it? Will it sink or float?
I'm sorry, say that again.
If you have a wooden block, like the kind you build with, throw it in a bucket of water, will it sink or float? You think it'll sink? It actually floats most of the time. Because wood is actually less dense than water. It has air and the structure and whatever. Now, if I took this quarter and I threw it into a bucket of water, what's it gonna do? I throw a quarter in a bucket of water, is it gonna sink or float? You ever seen a wishing well, fountain that people put money in? Where's it gonna go? It's gonna sink, right? Because its density is greater than that of water. Have you ever seen people like pour water and oil into a container together and the oil floats on top of the water? That's because the oil is less dense than the water.
I made a lava lamp for those things.
Yeah, those are cool. And I've also done a thing where I do different concentrations of a sugar solution. So you can, remember like last week we had super saturated solutions that we used. You can make less and less saturated solutions. So I do one that's like 80, 70, 60, 50, 40%. I make them each a different color. And you can pour them into a graduated cylinder or something that's long and tall, and they will lay on top of each other. So you get rainbow water. It's really cool. So what's luster? Do you know what luster is?
No, I haven't.
Do you know what luster is? So luster is how it reflects light. So how shiny is it? Is it a shiny mineral? Does light bounce off of it? Think about diamonds. Light bounces off of diamonds, right? Woo, shiny. Silver too, but maybe sulfur, not so much. Now this one's interesting. Cleavage and fracture. You know what cleavage and fracture are? All right, so cleavage and fracture, this has to do with how the mineral breaks. So a good example is this obsidian right here. So obsidian is igneous rock. It's formed from lava, right? I do.
It's really short.
And if you look at it, you can see, do you see all the little places where it broke off chunks? It's got like all these little, see there and there. You can see like on this big flat place, you can see. So, you know what they look like, right? You can see all the little places where, so they use this, if they could find this, they made arrowheads out of this, like Native Americans did.
Oh,
But
yes, I've
you
seen
can
it.
chip it down, and when you chip it, it breaks off in this perfectly flat plane.
I've watched videos of that.
Yeah.
It's the exact same.
So, yeah, it is. So some minerals are gonna break along a beautifully flat plane. It's gonna leave this perfectly flat piece when it breaks off. And others are not. They're just gonna crack open. So you have cleavage and fracture. So cleavage is when it splits evenly and beautifully along this perfectly flat plane. And then fractures when it just breaks. Most of the time, like if you get a piece of granite out there and you just whack it, it's just gonna break, right? But obsidian wouldn't do that. Color, you know what color is, right? Color is
Spelled
easy.
wrong.
Spell what wrong? Color?
Yeah.
Oh, are you trying to spell it the European way, put the U in it? So color is determined by the elements in the compound. So whatever elements are in the compound are going to produce that color. Remember last week we had copper in our compound that we dissolved in the solution. And what color crystals did we have with the copper? Do you remember? What color crystals we had in lab? Yeah, in lab, what color were the crystals? We had some white ones and then the ones that had clear ones. And then we had the copper, they were blue. Do you remember how they were beautiful blue, like a deep sparkly blue color? That's because of the copper. So-
Obsidian is really nice.
Yeah, obsidian is black, it's beautiful.
Have you seen the red obsidian yet?
Oh, the red, oh, I've seen pictures, but not in person. Pretty cool. So tell me about texture. What's texture? The way it feels, yeah, when you touch it, the way it feels. Is it smooth? Is it rough? That's texture. All right, so let's talk about how minerals form. So these are a little different. So you've got magma that cools, right? You know what magma is, right? What's magma?
Molten rock.
Yeah, magma is molten rock. What's the difference between magma and lava? Do you know, Cal, what the difference is between magma and lava? So magma is the melted rock when it's underground. Well, lava is melted rock when, what do you know? What do you think? When it's, so magma is melted rock when it's still underground. When it comes out and you can see it, that's when you call it what, you know? Lava, good. So yeah, so lava is when you've got magma outside, come to the surface of the earth. So magma is melted rock underground. And the center of the earth is, you know, as you get down towards the center of the earth, you get to go through magma to get to the core. So the rate of cooling of the magma and the chemical contents of the magma are going to affect what kind of mineral is formed. If the magma forms really quickly, you tend to get tiny crystals that form, and sometimes you get, if it comes to the surface and it's lava, sometimes you get pumice stone, which has holes all in it, lots of little holes in it. But if the magma cools really slowly, crystals have a long time. Yeah, you get big crystals, that's right, big crystals if the magma cools slowly. So solutions, that's another way minerals form. This is what you did last week. So super saturated solutions for precipitates that create crystals. So precipitates are what comes out of a solution. So have you ever seen pictures of like the Dead Sea, along the shore of the Dead Sea? Very salty. You can float in the Dead Sea. Like people get in it and just float really easily because there's so much salt in there that the water is more dense than typical and you can just kind of float. It's weird. But where it dries up on the rocks, it leaves salt behind, right? Because the salt is going to form its little crystals there once it comes out of solution. Remember in lab, we made super saturated solution, it was already saturated, we got it hot and put in more of the solute till it got to couldn't take any more. And then we put it under that heat light, which simulated what the sun will do, right? So that was the same thing as having it evaporate. We just sped it up a lot and we could see the little crystals that formed. So evaporates, this is what forms when you allow time and heat to take the water or whatever solute is in a solution and have it evaporate and leave behind things like the salt. So we had evaporates last week, all those little blue crystals, and they were beautiful. So how do we use our mineral resources? Okay, gemstones, this was our first one. So do you know what that stone is right there? That's an opal.
Opal.
Yep, so let's see if this works today. Hopefully it will. Okay, again, I don't have the sound. Hold on. He said to push. This thing is new here, so it's like, I don't know where to. He said it's the one that says. Hold on. Something done. Oh, hooray. And then it should work. Let me see. Please work.
This morning,
Okay, no. Will you have volume? Don't know how this thing works. It's making me crazy. Okay, hold on. This is gonna make me nutty. All this new stuff that doesn't do what I want it to do. Okay, I don't know where we're supposed to put it. Let me see if I can get him to come down and help me, and then we'll skip this and come back to it. So why are minerals valuable? Well, they're rare, and you please come help me make my video work. I can't do it. He keeps changing things.
I know a lot about technology, but I've never seen that thing about it.
Yeah, we'll come back to this one, and we'll come back to this one. So this is about ores. So there's gemstones and then there's ores that we both mine for. When you mine for gemstones, you're pulling beautiful, rare minerals out of the earth that you'll use typically for jewelry and stuff, but not just. Sometimes they use, like we said, use diamonds for things that cut, right? And then this is how they mine copper. They pull copper out of these big mines underground, and they have like blue walls and stuff, and it's beautiful, beautiful. Oh, here comes I did what you said. It didn't work. Oh, now it just kicked me off. This is not good. Here, let me put it back on. You said to do Blu-ray, and I did Blu-ray. Okay, then tell me what to do, because I don't know. Okay, well, hold on. Now it's kicked me off. This is making me crazy. I can't deal with this. Hold on. Hey, why is it up there twice? What the heck? Okay. There we go. Sorry, boys. I'm sorry. It should be working, but it just didn't do what it was supposed to do.
Hello.
Hey,
How are you?
you heading out?
Yes.
All right. You will see you next time.
It's just one class this year.
One
huh?
class this year,
Okay, okay.
in a little small group.
Wow.
They're cool.
It kind of
huh?
works out perfectly.
Yeah, it does.
It does.
Because I'm over here and you're over there, and it
Yes.
does, it works well.
Yes.
How are you feeling?
Good.
Good, good,
Yes,
good.
good. Just ready, kind of like,
Right.
yeah, like hurry up baking. you know?
Yeah,
Right.
you're tired of it.
Yeah, I'm already over it a little bit.
I
With the
understand
2 a.m.
that.
Wake ups of like gymnastics.
Oh, yeah,
there,
yeah, yeah.
yeah.
She was up all night, apparently.
Oh, yes.
He was not being friendly.
No, he was not. And no position was comfortable.
Oh,
It was one of those.
She had one of those long body pillows.
Yes.
that helped.
Yes,
Yeah.
that does help.
Yeah.
There we go.
What's your due date?
Second.
Ooh.
December.
Oh, December.
Yes.
Okay, okay.
No, not
I feel like-
anytime soon.
Because
We
my
have, like,
birthday is
3 more
September 23rd, so I'm like, woohoo.
Uh-huh. All right.
months. 14.
I have
Oh,
no sound. So he's got to help me figure this out.
Okay.
Bye-bye.
I apologize, guys. All right, let's see. So,
I'm done.
okay, you do.
Play.
Okay,
Why don't you stop it and share and play it again?
well, it shouldn't matter. No, it did not have sound before you walked. What'd you push?
TV audio.
Oh, I thought you said something about DVD. Well, why is it stopped? Oh, there it is. Got it. Okay,
It's the
But
TV.
mining black opal.
Here we
is
go.
easy.
there we go.
After investing tens of thousands of dollars, a miner might not find a single gem. So what makes black opal so hard to find? And why is it so expensive? Black opal is one of the most enchanting stones in the world, sought after for its seemingly infinite display of colors. Compared to common opal, which is usually one color, black opal exhibits many different colors, contrasted by a dark body bone.
It's simply the most stunning gemstone on the planet. It's just remarkably beautiful. You can put the thing away for a week, pick it out and look at it, and you can still see things inside it that you've never ever seen before.
Opal is found in several parts of the world, including Ethiopia, Brazil, and Mexico. But over 90% of the world's opal comes from Australia. And a lot of the black
Yeah,
here at Lightning Ridge. It's located on the edge of the outback, with a population of just over 2,000 people. Miners have been searching for opal here for over 100 years. But even for experts, finding black opal isn't easy.
If you were to start mining tomorrow, and once you learn mining skills, and I've been mining for 40 years, you can chance just because there's nothing really that can tell you, oh, there is opal in that piece of ground, or there's not opal in that piece of ground.
Miners start by drilling a vertical shaft in an area that they think contains opal. Then they must clear out an underground room large enough to start digging out the rock.
The basic idea of mining is basically extract the opal clay out from the ground, put it onto a truck. I take the truck to a puzzling site in town and check if there's opal in that.
The equipment needed to mine and the cost to register your claim can be extremely expensive.
Really, if you wanted to rock up here and be serious, you probably need 150 grand to 100 grand in your pocket.
But buying the equipment doesn't guarantee that miners will find black opal.
Some people will go, oh, there's definitely money there because next door they got $200,000 and there was a bit of colour drilled up here, it's got to come over, and there's a whole epic story of why there should be opal there. You go and dig there and it's not.
Miners search for areas in the rock with trace amounts of opal. They follow these spots called knobbies, hoping to find more opal deeper in the rock.
You'll keep going in a straight line till the trace runs out and then come back where there was trace in the wall, go left and right. And then if that stops, then you come back and do it again. You can come back and do it again. So you've always got that in the back of your head. You know, when do I leave? How long do I stay? Have I stayed too long? I'm wasting time. I'm wasting money for my next patch. There's a nugget there. When you have a really good product, there these nuggets are sitting close like that together. They can be like a cluster, like a bunch of grapes. They're all sitting around each other and they've all got colour. You know? Does it sound it's like glass? Just get the big one out. There we go. Doesn't have any value. Comment back opal.
Opal is formed when silica-rich groundwater hardens in rock over millions of years. Large silica spheres within the stone diffract light, creating vibrant colors. That play of color makes each gem unique. But for miners like Frederick, digging for black opal is a gamble.
The human factor is the biggest factor in finding opal. If you've got a piggy bank of $10,000 or $20,000, and then all of a sudden in 1 month or 2 months you've blown all of that budget because you've had breakdowns and you've had things that you didn't think of, and then you go, well, I'm $20,000 down. What do I do here? I've been full-time mining for about over 45 years, and quite often I'll say to myself, how did you do it? You know, how did you survive that long, making it your only job? I've done good, not great. I haven't been in the millions. I haven't been up there in the fantasy pocket, you know.
Once rough opal is extracted and processed from the dirt, it has to be cut and polished. This is when the real value of the gem is determined.
A black opal can vary from starting at maybe $1,000 a carat for running of your mill and going right up to tens of thousands of dollars for that really exquisite top quality. The main stone is 241 carats. A few $1,000s
That's
a carat
incredible.
would be unreasonable. A lot of money.
The color, brightness, and patterns can all influence the price of black opal.
What you're looking for in the best quality opal is a black stone, really bright color and as much red and other colors as possible. So the most valuable black opal of all is a really bright red stone on a very dark base, and that just glows. And you don't see them very often at all.
That lack of supply is a huge driver for the price of black opal.
We can barely keep up with the demand at the moment. As soon as you find a gem quality stone, you know you've got to buy it for.
Between 2005 and 2006, approximately $30 million of opal was mined at Lightning Ridge.
It's a lot of
And
opal.
for fans of black opal, there's simply nothing else like it.
Just a magic stone, and when it came to Lightning Ridge, it
$30 million
just the beauty
opal.
of it captivated me.
What a pretty
It's an
place.
awesome job. I would love to find 2 or 3 more good claims, like 1 more good patch, get rid of the debts that we have and set it up and offer the opportunity for my son to take over the job.
So you can see that for gem mining, there's usually, at least they're starting a mine, there's a lot of risk, right? You might start a mine and find nothing. You could tap away on the rock all day and find nothing, but then you might find a good size opal and another one and another one, and that makes it worth it. And that's just opal. I mean, there's certainly similar situations for a lot of other gems. And then we talk about ore. So ore is when you find, it's when you find an element within a rock, like iron or silver, or in this case, copper. I mentioned last week, I think I mentioned it to you guys, copper, we talked about pennies and how they don't have copper all the way through anymore. And that's because copper is super expensive. So expensive that people will go into empty houses and pull out the wires and strip the wires down, get the copper out of the wires and sell it because copper is so expensive, huh?
Not me.
Yeah, that's not good. So this is a copper mine, and this is in the UK. It's Cornish, so it's in Cornwall, and so it's got that crazy name is a Cornish name. But this place is gorgeous. I would love to see this place.
Hello and welcome to another Benno Cam lockdown edition.
This guy just goes into mines for fun, and nobody seems to stop it. It's interesting.
Just up the valley.
Some of it looks crazy dangerous.
It's got a few interesting pictures. Look now. I normally always explore with people, but today's been an exception. It's a beautiful day. I know this line very, very well, so it's considered pretty low risk. I've let people know where I'm going, what time off they're going to be back. So let's do it.
Tyburn Hale mine sits on the north of a valley close to the coastal town of Porthcawen. The mine's engine house on Taylor Shaft remains visible on the hilltop from many miles away. And this mine had one of the first mine shafts in Cornwall to be drained using an electric pump. This mine started life as Wheeled Rock in 1750, was renamed United Hills Mine in 1809, before becoming known as Tyburn Hale in the early 1900s, when it started to be used as a training site for the Royal School of Mines for Imperial College in London.
Oh, hold on. I did just turn the volume down. Oh, come on, really? No, keep walking, dude. You were here. We're walking into the mine. There you go. Technical problems. There you go. I don't think I want to do this by myself. This looks a bit risky to me. Wait till you see what he climbs on, like climbs on this old wooden stuff.
Prop still left in position here in the stoke, and
Long way to
this
go.
is where we're going to go. We're going to go down into this lower part.
See all that blue? Isn't that cool?
Now at this point, you just get the first glimpses of the copper bearing rock which is surrounding us. So you can see here the copper residue slowly leaching out from below. This is the area of metal they were after, the ore above us. And you can see these beautiful colours coming through. So there's obviously still some copper still in this rock they left behind. They were crawled down through some stapling now. And we're going to go right on through here and link up with the deep adit. A little bit narrow, as you can see.
See, they use those rocks to build the walls in there. And look at this old rickety stuff. He's just climbing on it. It's all good. It makes me nervous, this guy.
Okay, we've reached the deep adit section of the mine now. So we're going to use this to further access the rest of the working. Okay, we finally reached the stoping. So you can see here the timbers, this large space that's all been stoped out there right up. There's a nice rope there that's been left later on, and we're actually going to climb back down there. We'll go around in a full circuit. Another shaft, a bit more junk. A lot of water coming down this one. And some lovely copper stains in it. Try and get you a little sneaky look, looking up. It's a bit wet. Few nice iron rails here underneath on the floor. You can just about make out here. It's quite nice to still see the rails still in place. Not a lot of mines. They left them in, they used to pull them out as they went. That's quite nice to see. So we've got
pretty.
a nice bit of stoping on top of stoping.
No, it is.
Definitely a lot of
You
ore
wanna
and
be
metals
there?
around here, which they're after.
I don't want to be in there.
I mean,
And
man,
chase these veins right up to wherever they need it to be to get it.
So you get the idea. This guy goes underground and finds all this copper that's still there. Whoop, whoop, whoop. All right, so smelting. The last thing to talk about. Smelting. Okay, so smelting involves heating up ore. That's what he was doing. He saw copper ore, right? Until the metal becomes spongy and the chemical compounds in the ore begin to break down. Most important, it releases oxygen from, in this case, iron, for example, which makes up a high percentage of common iron ores. So you find iron ore and there's a lot of oxygen in it. There's rock mixed in with the actual metal. So they heat it up and the metal starts to melt. And as it comes out, the iron starts to melt and comes out, all the oxygen and whatnot comes out of it. And then you get your pure iron that you're going to use to make structures or build or, whatever you're going to do with it. And the most primitive kind of smelting facility was called a bloomery. Now, if you go now and look at what our facilities look like, they look like the one on the bottom. They really do. They look just like that. Even though that may look a little old, that's exactly how they look. We still do it like that. But back in the day, they did it like this. See the thing on the top? So that's a bloomery. And so this is a metallurgical furnace, meaning it's meant for metal. So they would build this thing with brick and stone, and it's that shape. See the shape of it's kind of like an upside, it's like a bell. See the shape? So this is what they used for smelting way back in the day. So they would take iron and they'd put it in there, and it would produce iron which was more, still had some oxygen in it, not as good as our iron, and that produced something called slag. So slag is the leftover. So you may have heard of slag glass. Slag glass is also the leftover too. Like if you are in like a glass working facility, there's little bits that fall and hit the ground and they don't use them and just kind of land everywhere. That's slag glass. And sometimes they'll take that glass, melt it down and reuse it for other things. And they'll be like slag glass pitcher. You may see that. It was real popular back in like mid-century. So 1950s, there was a lot of slag glass stuff. But there's slag when you smelt ore, and that's kind of all the leftover stuff that you don't use. And that's what's at the bottom. So looking at your binders, if you want to check your answers. So how do minerals form from magma? So when magma cools and the liquids become solids, they form the crystals. And that's where your minerals come from. So how do minerals form from solutions? That's the other one. So minerals come from two things, magma and solutions. And when they form from solution, it's because they're usually evaporates, right? They're left over from
is
evaporation.
this supposed to be the second question on that?
Yeah, the second question that you would ask is how do they form from minerals? How do minerals form from solutions? Because minerals form from two things, magma and solution. So this one tells you, the second question would be about solutions. So the process by which atoms are arranged in a material with crystal structure, that was what we call crystallization. Can you find it? Do you need help? You should be right there behind this. Yeah, there you are. Right, we're on, right here. Great. All right, we're just gonna whip through these while your rest of your class is waiting. So two ways minerals form, we just said it, from magma and solution, right? Magma and solution. So those are two ways they form. Yeah, that's fine. But they also form underground. So that's magma. That's magma when it's underground. So what affects the size of crystals from magma? Right. How quickly or slowly it cools. Slowly produces bigger crystals, right? Because it has more time to cool. That's what you're looking for. Bigger crystals. Money's kind of going everywhere. All right, so why does magma that cools deep below the surface have large crystals? This is what we're talking about. Why is it? Yeah, it had a long time to cool, which meant it had a long time to grow. So the magma that's way deep underneath cools more slowly, and that's where you get these big, beautiful crystals, and money's everywhere. So is this true or false? Lava cools quickly and forms minerals with small crystals. You have your answer, Cal? What'd you put? Top of the second page. Number 4. It's, I'm sorry, number 5. Is it true or false? Lava cools quickly and forms minerals with small crystals. Yeah, you got it. Good. So a mixture in which one substance is dissolved in another is called a solution, right? So is this one true or false? Minerals can form when solutions evaporate. Yes, that's true. Very good. So circle the letter that's true. So these are the ones that were true of this. When you keep going, click. So in the book, it talks about where you can find halite deposits in the US. Okay, okay. So the next one is, I already clicked it, but how do minerals form from a hot water solution? The word is precipitate, right? That means they come out of the solution and solidify. So a narrow channel or a slab of mineral, it's a vein, right? We talked about veins, and you could see in that guy's video, there were copper veins that ran through and left a thing in the middle. So this is how they form. You get a crack in the rock and your mineral solution comes in there, or your magma flows in there. And over time, it cools, solidifies, and you get yourself your vein. So here's these. So we can use gems for jewelry and mechanical parts, grinding and polishing. You could put any examples of metals in there: copper, silver, gold, nickel. So metals are malleable because of the structure of the metallic molecules. You can bend, mush, and change their shape. So uses of metals, lots of them. So how about this one here? Talc talc is used in powder. Calcite is used in microscope lenses. Quartz is used in watches, and gypsum is used in cement. And then this last bit here, a rock that contains a metal or economically useful mineral, we call that an ore. Most metals occur in pure form. That is false. The one that does occur in pure form is copper, typically. And so here is your last one. I'll give you this one to look at. So the word you came up with should have been fluorescence. All righty. So let's start our lab. I'll stop the class. Goodbye. All right, there we go. And this one. And that. All right. So Drew, can you tell everybody to come on in?